All right, so respected Director Sir, our foreign guest, Professor Jean-François Roch, head of the department, and the participants. So it is a great pleasure that we are commencing this Gyan course on quantum technologies. And this course was actually, the idea was, he's our Dean R&D, Professor Sudeep Mandal. He is Professor Jean-François Roch. So the idea was actually coined when I visited France before COVID, and then we somehow agreed that we will float a course. And then a lot of disruptions came, but we persistently continued, and I think I thank him for the perseverance and being patient with our system. All right, so the plan of the morning is that I will give a brief introduction to the course overview, and then followed by our head will welcome the guest, and then I will also request our Dean R&D to say a few words, and then I will request our director to welcome the guest. And Professor Jean-François Roch, he also has requested that he would like to give a brief overview of the quantum activities going on in his laboratory. All right, so let us begin with the brief overview of the course. So the course is on color centers in diamond as solid-state artificial atoms for quantum technologies from 6 to 10 October. And the course will be delivered mostly by Professor Jean-François Roch, and I am the coordinator of the course. So the broad theme of the course is that we all love diamonds. However, there are some atomic scale defects in the diamonds which are acting as a color centers. That means they emit light of specific colors. And in the course, we will discuss how these color centers work as an artificial atoms, which are quantum objects embedded inside the solid-state matrix. So we will learn about various kinds of defects in the color center, especially silicon vacancy center, nitrogen vacancy centers. We will learn how do we characterize them, how do we isolate them, how do we study their different optical, spin, magnetic properties, and what are the different applications of these color centers in quantum technologies. One of the very interesting aspects is that we will also make practical demonstrations of quantum measurements. So Professor Roch will ask his team in France to do some live experiments, and we will try to broadcast that here for the participants. And in our lab also, we have a small quantum setup, so we will also take participants there, and they will be able to see the hands-on experiments, and it will strengthen their theoretical concepts. So it's both theory and experiments that will go together. And overall, this theme of the course has many applications, like generation of single photon sources, quantum sensing, magnetometry, quantum information. And these nitrogen vacancy centers in diamonds, they also have applications in biology. For example, they can probe the structure of protein precisely. There are experiments where they are able to measure the temperature within a single cell, the distribution of temperature within a single cell, and brain imaging, and so on. So the course will run for 5 days. There will be 15 lectures and tutorials. Our foreign faculty is Professor Jean-François Roch. I'm the coordinator, and we have got very good response. We have 34 different participants, mostly students and postdocs. We have participants from IIT Ropar, IIT Mandi, and one participant from University of Copenhagen. There are 5 different themes of the course, each devoted to one day. And the uniqueness is, of course, that there will be direct exposure to the experimental techniques and hands-on experience. I would like to say a few words about Professor Jean-François Roch. He is Professor de classe exceptionnelle, which is highest ranked professor in a French university system at École Normale Supérieure Paris-Saclay, France. He has very broad research interests. He studies atomic defects in diamonds, single photon generation, nanoscale photonics, high pressure physics, subjecting material to pressures million times larger than the atmospheric pressure, NV magnetometry, and spin physics for quantum information. His academic trajectory is he did graduate studies 1984 to 1988 from ENS Paris-Saclay. In 1987, he passed Agrégation de Physique, which is a French national professorship competitive exam, and he secured an impressive rank 3. He did PhD in 1992 from University of Paris-Sud in France. Then he has been CNRS researcher from 92 to 96 in Institut d'Optics in the group of Philippe Granier. He was also CNRS researcher 96 to 98 in Laboratoire Castor Bruxelles in the group of Sergei Harosh. And since 1998, he is full professor at ENS Paris-Saclay. He has held various academic responsibilities. For example, from 2008 to 2011, he was director of multidisciplinary doctoral school at ENS Cachan. From 2009 to 2011, he was vice rector of ENS Cachan. From 2012 to 2017, he was director of Laboratoire Emo Coton, Orsay, France. From 2015 to 2023, 8 years, he was elected president of Council Scientifique Restreint of ENS Paris-Saclay. From 2016 to onwards, he has been a member of the steering committee looking at the quantum technologies development in the region of France. And since 2021, he is also director of Interdisciplinary Center of Quantum Saclay, aiming at development of quantum science and technology at University of Paris-Saclay and Institut Polytechnique, Paris. He has published phenomenally. He has 150 plus publications in journals like Science, PRL, Optics Express, very reputed journals. He is routine delivering talks. He has given 100 plus invited plenary lectures in international events. He has two book chapters. He has also been awarded with numerous awards. For example, in 2024, he got Jeff Prize and Berthollet Medal of French Academy of Science. In 2021, he was elected senior member of Institute University of France. And in 2017, he was elected as Overseas Fellow, University of Cambridge, UK. So with this, I would like to extend a warm welcome, Professor Roche, to India. And I wish all the participants a happy, enjoyable quantum learning week. And I would like to thank our director and colleagues for gracing the occasion. And last but not least, we have a very dedicated organizing team in our lab, Biswajit, Nikita, Jayant, Bhupal, Priya, Pooja, Amar, Shivam. So they have put a lot of efforts in coordinating various activities. So big thanks to them. All right. Okay, so I would now request our head of the department to welcome the guest.
Very warm welcome to all of you, to Professor Rock, for coming here and for coming to deliver these lectures, set of lectures, and to all the participants and Professor Tripathi, our director, and Sudeep, our Dean R&D. And of course, the bulk of the work has been, of course, done by Kamal, who has been who consistently been organizing these Gyan conferences, which have been very, very helpful to a large number of students, of the participants, specifically from various corners of India and some abroad, as I got to know. Somebody is also joining us from the University of Copenhagen. So I would just like to say that this is indeed a very nice topic, because we take great pride in our interdisciplinary part of our curriculum here at IISER Mohali. And this particular topic kind of does that justice, because it takes quantum optics and material science and solid state physics, all these things together. So in a way, within the interdisciplinary, within the physics part of it itself, there is various parts of it connecting together. To the participants, of course, I would like to say that this is a very good opportunity for you to listen to these lectures and also participate actively, ask questions, and discuss, because you have a world-renowned expert who is going to deliver these lectures, and with the demonstrations that are there, as Kamal pointed out, we really hope that this will help you in your future research pursuits as well. As we all know, and as you are aware of as well, that this quantum technologies is not just a future of physics, but it's also the future of technology. So how that comes about and how we can use it in various aspects is something that I hope that this particular conference with this particular school does justice to that, and I'm sure it will. I'm looking forward to it, and with a lot of fruitful discussions between both the instructors and the students and the participants. With that, I would like to again extend a very warm welcome to Professor Rock and to all other participants, and on behalf of the Department of Physics, welcome. Thank you.
So, a very warm welcome and good morning, Professor Roche, Professor Tripathi, Abhishek, and Kamal, my colleagues, and my dear students. We are starting after one of the biggest festivals of our country. We are all fresh, we are happy, and we are going to start a new course. Professor Kamal has been the coordinator of the GAN course for the entire institute, and he coordinates of all the GAN courses that we have in IISER Mohali. And today he is the coordinator of his own GAN course. And I think you were doing is the second or the third one? Second one. So I am very sure that with his expertise and the expertise of the Professor Roche, who is a world-known scientist in this area, you will learn a lot. You will have a wonderful stay at IISER Mohali. Specifically, the hands-on experience will give you a lot of, what I should say, understanding of the field, and you will know much better, and in future you will apply them in different ways. I wish you a very happy stay in IISER Mohali. And one thing I will say that, it's a wide campus. I know you will be busy with your coursework, but do feel to get out of this area, mix with others, talk to other scientists, talk to other people, and that will enrich you in different ways. And at the end of the course, I think you have an evaluation process also. So I wish you success in that evaluation process. I'm sure you will do well and have a great time and a wonderful experience. Enjoy the science. Thank you very much.
Most welcome to India, to Chandigarh, to Mohali.
Thank you. Thank you so much.
So good morning and congratulations for getting this opportunity of interacting with one of the most eminent. Okay, I think. Okay. So congratulations to all of you for having got this opportunity of interacting with one of the world's topmost experts in the field of quantum technologies. I could see from his CV that he belongs to a class of Professor Exceptional. And this I know because way back in 1999, 2000, I had a French collaboration under this same scheme which Professor K.P. Singh has, Indo-French Center for Promotion of Advanced Scientific Research. CEFIPRA, and my collaborator was also Professor Exceptional. And therefore, I know that there are very selected few scientists, topmost scientists in France who fall into that band. And so this is highly prestigious position. So we are very fortunate that Professor Roche is here. I'm not sure how to pronounce, because I was in France, I think 3, 4 times, 5 times, but every time I had difficulty in pronouncing the French words. Since I'm not a man of physics, so I can cut some jokes. So I really appreciate what Professor K.P. Singh Kamal Priya Singh was pronouncing it, to my understanding, quite correctly. So it's very difficult for me to pronounce it correctly, because my French collaborator was Daniel Lerodoulier, but they will pronounce this Daniel Lerodoulier. So likewise here also, I came to know that when you listen to him, some French accent, you should try to understand that. I was told that there is a word called station. If you have to pronounce it in German, it's station. And if you have to pronounce it in Italian, it is stazione. And probably in French, it is station. So, similar words, the same words, but pronunciation are quite different. And my problem became more aggravated because I spent time in Germany where they pronounce as it is written, like bus is not pronounced as bus, it is pronounced as bus. So in France, the pronunciation is quite completely different and quite complicated. Anyway, so just some amusing part apart, I think it's a great opportunity for IISER Mohali and participants from IIT Mandi, IIT Ropert, and IISER that Professor Roch is here, and he will be sharing his experience, some live demonstrations with you. So this endeavor of Professor K.P. Singh to organize such courses requires a kind of initiative, a kind of enthusiasm to make arrangements, to be a nodal person, to transmit knowledge to the students and seekers of knowledge in India. So I really appreciate the effort of Professor K.P. Singh in organizing this course. As you might have you have heard from him, it takes a lot of effort. And I also really appreciate Professor Roch for deciding to come back to India after a long time. I think about 25 years before he was in India, and now the India has changed quite a bit. And so if he goes around, he will be able to see the changes. But I think this city should have some French connection from Le Corbusier. I hope you'll have some time to see the creation of Le Corbusier in Chandigarh. And to all the participants, I would just submit that take maximum advantage of his presence. And I would also like to request Professor K.P. Singh and Professor Roch to enter into some kind of agreement, memorandum of understanding, so that we can have a closer interaction with Professor Roch and his group. And this institution already has a lot of strong foundations in quantum sciences, quantum technology. There are several people who are working in this area. And this kind of interaction will make our center more visible, more impactful, and more relevant for the country and its needs. So with these words, I once again welcome all of you, especially Professor Roch, and thank Professor K.P. Singh for organizing this event. Thank you.
Now I request Jean-François Roch to please say a few words. And you want to show some?
Yes. Come in. No, 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 no. Let me see if it works. It worked before, so it should work again. Let me see. Should find it. Yes, I think it's going to arrive. Yes. Good, good, good. I think I see the problem. Let me see. It's a copy of the screen. Yes. Sorry for that. So, many thanks for all these kind words, and it's really a great pleasure to be here, and a great honor also to have been selected for the prestigious JAN course. I think this is very important. It fosters international collaboration, it fosters exchanges, and this is certainly one thing that we need now at our time. So you actually pronounced my name very well. So Roch, it's how it should be pronounced. A little bit like it would be a K in English, rock. Like it's a little bit like that. You say Roch. Now I do agree that pronouncing French name can be very difficult. For instance, if you wouldn't have that, that would be Jean-François. And with that, it's Jean-François. So like a S. So, you know, I can imagine how difficult this is. Okay, just to start, I would like just to show you a little bit the environment where we're working. So we are at the University Paris-Saclay. So the University Paris-Saclay, it's a very large university now, around 70, regarding European standard, at least 70,000 students. But it's actually it was founded something like 6-7 years ago by merging different academic institutions in France. And among them, there is actually my institution, the École Normale Supérieure of Paris-Saclay, and I will show you. So during the past years, there was a huge refurbishing work and new construction getting on. So you have here, so the campus is quite large. It's 4 kilometers of distance, and it's actually larger than downtown Paris. Downtown Paris, only 4 kilometers. Of course, there are the surroundings nearby, and there are basically 2-3 parts in this campus. Here, for instance, this is a little bit old pictures about, you see, it's still some construction work here. That's actually the swimming pool now. And the swimming pool does exist. But then you have different academic institutions like our school here. I will show you more detail. The École Normale Supérieure. It was before that in Cachan, and Cachan was a small town close to Paris, and we decided to move to join this big cluster when it was actually, that was when I was vice rector. The decision was taken at that time. And then there is a very famous also engineering school, which is called École Centrale, one of the two most prestigious engineering schools in France, and also all the university laboratories and teaching departments. For instance, the physics teaching department should be somewhere here, actually. That's where the physics teaching department here. So I have to go from here to here. So it's a 10-minute walk distance. And what is also important is that there will be opening next year, hopefully there will be a new metro line which has been constructed and that will link to Paris with fast metro link. Which unfortunately is missing at the moment. So just to tell you, and what's amazing was the fact that something when I started to work in this area for my PhD, now a long time ago, there was, all that was lands, really did not exist. And seeing that is indeed quite impressive, at least regarding our standard for making new things. This is our school. So you may, so somehow the university is a kind of umbrella, a little bit like the Cambridge and Oxford system in UK, where you have under the full university system, you have some colleges in Cambridge and Oxford. It's a little bit the same. So for instance, would be somehow a kind of college in the UK, in the English system. And here the building opened in 2020, actually just before COVID, and that's how it's organized. So you have a large building here where you see here the interior of the building, and our labs are located a little bit that on the third floor. That's the third floor. So you will, I hope that the link will work so that you can have a tour of our lab in Paris, and at the same time we will try with my PhD students to settle some online experiments. Hopefully that should be on Thursday so that we have time to prepare that. And there's a very nice garden here, and when you enter here you have these two blocks. One is the theater, and this is our large amphitheater, and the name of the amphitheater is Alain Aspect, since Alain Aspect was an alumni of the school and got Nobel Prize a few years after. Okay, so then you see the environment. What I'm actually doing, and it's my only responsibility, is I'm the director of a federative center that was founded for the development of quantum technologies. And somehow the center has also is affiliated to different institutions, the university, the Institut Polytechnique de Paris with the École Polytechnique de Paris. It's also a very prestigious engineering school. Two research organisms, because in France we have this dual system that mix university on one part, universities and national organism. The two national organisms that are involved is the CNRS, of course, and the Center for Atomic Energy too, which has a very strong program on quantum for the development and quantum technology, and two other organisms of smaller size, INRIA, which is devoted to computer science, and of course there is a lot of ongoing work on quantum computing, for instance, for the development of specific algorithms, those kind of things. And ONERA, which is an organization devoted to airspace industry, and to have a link, to establish links with the aeronautic industry. And ONERA is very active also on quantum sensing, especially for navigation, positioning, those kind of topic, and that's why they are involved in that. So I just wanted to show a little bit in what we are doing in this center. So it's not a single institute. It's spread in many laboratories. There actually it gathers around 100 teams. And what's also maybe worth saying is the fact that many experiments that pioneered what is now called the second quantum revolution after the one in the 30s, where some experiments were really realized at the University of Paris-Saclay or in the neighborhood. So, of course, the first experiments for quantum entanglement and Einstein-Podolsky-Rosen test was done by Alain Aspect in '82. Development of the first single photon source was also done by Alain Aspect and his PhD student Philippe Grangier. That was in '86, and we started after that to do other developments of single photon source. I will show you a little bit, and apply them to quantum cryptography. Superconducting qubit was also pioneered at the Center of Atomic Energy by Daniel Estève and his team. And there's beautiful ongoing work now at the moment in this team where people used the superconducting technology that has been developed for qubit to do magnetic resonance at a single, a level of accuracy which is unbelievable, which is that you can probe really a single nucleus spin, detect its environment. So it's beautiful experiments. And there is also a very nice and somehow connecting work on spintronics with the Nobel Prize of Albert Fert, who discovered giant magnetic resonance. And there are also links between the quantum technologies that we are developing and spintronic community. And somehow we're working in all the different topics: quantum computing, quantum communication, quantum sensing. Most of the lectures I will do will be devoted to quantum sensing using NV centers. The development of also investigating quantum matter, and there's a nice connection. That's actually my topic at the moment, is how to use quantum sensing to probe quantum matter, and also the development of enabling technologies for those kind of research. And what is also important is to say that our center was benefit from the French National Quantum Strategy that was announced by our president, actually also in Saclay at the Center for Nanoscience and Nanotechnology a few years ago. And it's an effort that is around just around 2 billion euros that was spent on this topic. And basically, this is how it was declined in a lot of small tasks. And I'm especially involved in this program, which funds PhD and the development of quantum teaching activities. And also what we have, somehow we try to cover with the center basic science, transfer to industry, strong links with big industrial group like Thales, for instance. I'm actually worked in Thales for a few years, where we developed experiments for magnetic measurements. They were coming from the labs, as there was a very successful startup. Now it's not anymore startup. For instance, Candela, which is exploring the use of single photons for quantum computing and quantum communication, is around 200 people, and I think it's even more for Pascal, with developing quantum computing devices based on Rydberg atoms and their interaction. And this somehow is developed in 9 research labs, joint research lab between linking academic team and such industrial partners. And that's somehow the ecosystems for the development of these activities. Aside that, we developed a training program, so a PhD program first. We attribute around 30 PhD grant per year on the topic, and there are also grant funded by resources that researchers can have. And we started also an Erasmus Mundus joint master, which is funded by the European Commission, and it links the university with the Sapienza University in Rome, the University of Porto, and one foreign university outside Europe, the University of Toronto. And the student can be involved in this master program. It's a 2-year program, where basically spend a semester in one of those places with the obligation to move at one point. And within that, we organize every year to gather all the students a school, which is usually organized in Italy. Last year it was in Palermo, where all the students somehow that are spread out these different places mixed together. And within that, for instance, what we have been developing is a quantum engineering teaching lab. So somehow now we spread this activity in different, on different curriculum within the university. And basically you have practicals on test of Bell inequalities using entangled photon pairs. You have something where we are quite proud of, because now we have an experiment where students can really work on a superconducting qubit. And now at the same time we have systems to do magnetometry with NV centers, a little bit what I will show you. The student can build a single photon source, test that it's indeed a single photon source by assembling a confocal microscope and detecting a single NV centers. And associated to that, there is a strong activity on microwaves, because microwaves, as you will see, are very important in all those kind of topics. And basically you can learn within 1 week, that's the idea, about what the basics of microwave, that's very electrical engineering, for instance. You can build a circuit, a microwave circuit, and actually you make the circuit actually by computer design, the circuit that will be this superconducting qubit. And now using such systems, for instance, you can control it in real time and operate it. And that's somehow the circuit that was built. So you design it using computer software. We're using some dedicated software that was, of course, realized in a clean room facility, and then it's put in the fridge, cooled down to around 100 millikelvin, and then you can operate that with Rabi oscillations, get control, and those kind of things. And we hope this year to settle now a 2-qubit in the chip, in the superconducting chip, and using that, the students will be able to perform quantum gates like CNOT gate or whatever, with readouts of the system. So the kind of thing that we want to do. So the main purpose of these activities is really to take things that were developed in the lab, something like 10, 20 years ago, and really now transfer it to hands-on experiments, hands-on activities. And that's very nice. That's something that I really like a lot. Okay, thank you a lot for that. Just a very quick overview.